Welcome back to the third and last part of this tutorial. We have here our quantum GIS. I open the orthophoto done with the drone. Here it is. Now I load the shape file of this shelter that we have done previously with Global Mapper. It was called vector shelter row. Okay, here it is. This row shelter shapefile has a lot of geometrical mistake, therefore we have to fix them before starting with the other analysis. To fix the geometrical mistake, you need to display the processing toolbox. If you don't remember, just go to processing and toolbox, and here just type fix. You will get the fixed geometries under the vector. Click twice and click run. This shapefile is rather heavy, therefore this process might take a few seconds. In my case it takes around 4 minutes. Of course this depends as well on the capacity of your computer. Now before I lose everything, I save it. Fine. We have now created a temporary layer called fixed geometry. If you check the property of this shape, you will see that these shapes, they have only the color as value, nothing else. But what we need is to have as well the area or the perimeter. To create the area of a perimeter of each shape, you can do it either manually using the field calculator, or you can use a command called convex hull. This you find again in the processing tool. Convex hull, it is here. This time we choose the fixed geometry layer. We run it. If you don't fix it, this command will not run. Fine. Now we have a new temporary layer called convex hull. If I check the property of this shape, you see now we have the color, the area and the perimeter automatically. Let's zoom in. You see now we have all our shelters and plenty of noise. Let's see what is the average area of one shelter. For example, this one. The average area of one shelter is around 18.5. So let's delete everything which is smaller than 15. First let's zoom to layer. And now to delete everything which is smaller than 15 square meter, you go to the attribute table, you filter, and you write that all the area which are smaller than 15 must be selected. You see the machine selected 80,806 shapes, and we can see it has also selected some shelters. So let's go smaller in that case. Again, I want to filter. I want to select everything which has an area smaller than 14. Select, and how I have kind of better result. Just here some mistake. Let's zoom in and see the details. You see all those shelters, they are rather small, but all these small mistakes have been selected. Now I will delete everything which is selected. For that I'll click on convex hull, I activate the editing button, and I just click on delete selected. 80,777 features are going to be deleted, and now it starts to be better. Now I will delete the big areas like this one. I do the same process. I click the attribute table, I filter everything which is bigger than, let's say, 20. Select features. Now it selected only 57 features. Okay, and I delete them as well. Okay, fine. Now we have that. Let's compare with our image to see where we stay. For some reason the computer did not detect those few shelter, probably because they are very small. It didn't select those shelter because they are below the trees and definitely too small. but fine, it's not a problem. We have now to correct the rest manually, therefore I call this process semi-automatic classification. To do it manually, simple select one well done shelter and not too big. For example, I would take this one. With this icon, copy and move, just move them here and correct it manually. It's up to you if you want to count this as a shelter or not. It was definitely a shelter, but it is not used since it's broken, but I copy it. So here below the tree. Of course, this process can be a little bit painful, especially if you don't have geometric shelters like that, but there is no way for the time being that I know. So you do it, you correct it manually, but definitely this process is quicker than doing all the shelter manually. Like that. Where you have bad shape shelter, you could rebuild it and so on. For example, those shelter is not well done, so I delete them. This also is not well done, I delete them. Okay, and you go on. Of course, you have also some shelter that are actually not shelters. For example, this is one. It's, I don't know what it is, just let's delete it. Here we have some mistakes, and definitely those are not shelter, and so on. So manually you clean up all the shelter, and at the end don't forget to make this layer permanent. I call it shelter filtered. At the end you should have a solution like this one. Once you have your shelter, you can count them. In this case we have 941 shelter. We can calculate the density, we can calculate how many displaced people per shelter we have in this area, and many other parameters. Thank you very much for following the third and last part of this tutorial, and see you soon.